Happy to have you this lesson, and I'm happy to welcome you to term 3 work P7. So if you don't have a copy yet, you had better hurriedly come to school. That is at Train Up a Child Primary School, Bugolobi branch. You can as well use the other sister branch, that's Najanankunda, and acquire yourself a copy so that we go together. So in this booklet, specifically, we have a topic called length, mass, and capacity. We thought it right to have that topic last because it is actually lengthy. It involves those three, of which length is the longest, like the word length suggests. So when you watch this lesson, you will then be able to answer all the activities from page 1 all the way to 8 of that newly acquired workbook term 3 P7. Then you will enjoy this topic, length, mass, and capacity. And now I urge you to follow strictly because it's one of the sensitive topics which are mainly failed at PLE level. Now we describe each of them, length, like the word length suggests. So it's how long an object is in terms of metric units like kilometers, hectometers, decameters, meters, centimeters, decimeters, millimeters. So anything to do with meters is talking about the length. Then mass is how heavy an object is as measured in grams, like kilograms, decagrams, anything to do with grams, centigrams, milligrams. So that is the mass. Then capacity simply means volume in liters in this line, please, in this perspective. It can mean something else, or it has got several meanings. But here we are looking at volume in liters specifically. So that is the capacity. So then we start. The example number 1, please, I urge you to follow so that you can answer all the activities, not only from page 1 to page 8 of our workbook, but also others that you will find concerning the same discussion. Please, let's then go together. So, number 1 reads, when sprinting, Ivan the athlete covers 180 centimeters with every stride. Then the question is, how many strides does it take to finish this 100 meter sprint? 100 meter sprint. Here you must know what a stride is. If you don't know, I'm here to tell you that distance between your feet while walking is called a stride. Like now, I'm making strides. A stride, a stride, a stride, and then I turn and make strides still. Stride, stride. So that distance between your feet while on the move, while walking, while running, so it is called a stride. Now, this one has got a length stride of 180 centimeters. My friend, this one's got the whole stride of 180 centimeters. So 180, every stride he makes, he covers a 180 centimeter down ground. So 180, 180, 180. So, and now, how many such 180s will make a 100 meter sprint or journey? Now, the problem we have here is that you have got 2 different units. You see centimeters here? Yes. You see meters here? Yes. So, whenever I've got 2 different units, we harmonize them we ensure they are the same before anything is done. Before anything is done. So normally we convert the greater unit of the two to a less one. So the meter is far greater than a centimeter. So we convert the meters to centimeters first. So we say meters to centimeters. We know 1 meter is equivalent to 100 centimeters. Then what about 100 meters? It would be 100 times 100 centimeters. Where 1 times 1 is 1, then bring all the zeros. It is very interesting that in multiplication, all the zeros must be used, must be catered for. So I've got 1, 2, 3, 4 zeros against 1 and get that 10,000 centimeter length. So remember, this Ivan 30 covers 180 centimeter per stride. That's every stride. So the question is, how many 180s are involved in the 10,000 centimeter length? So go 1 centimeter is an equivalent of 1 stride. What about the 10,000 centimeter length? You get 10,000 divided by 180 answer in strides. Then you cancel. So you start dividing by 10 by 10. So you are left with 1,000 out of 18. 1,018 are both divisible by 2. So 18 divided by 2, you get a 9. And then 10 divided by 2, get 5. And these 2 zeros. And get 500 out of 9. This out of means divide by. Now, 500 out of 9 is an improper fraction. So what do we do? Whether divisible or not divisible, and it is not divisible by 9, we must divide by 9. So let's divide by 9. 9 divided by 9 works. 50 divided by 9 is 5. Why? 5 times 9 is 45. And this is the 50, meaning 5 remains. So the remainder is put on the next 0. There remains a 50 again. Still we have divided. So the experience has shown 5 times. So 50 divided by 9 is 5, still remainder 5. So I've got 55 and 5 out of 9 strides. So this will make 55 full strides. Then the other one that will make the last one will be just a small one, which is a fractional stride, which will be a 5/9. So therefore, we've got 55 and 5/9 strides will go as long as a 10,000 centimeter sprint, that is equivalent to 100-meter sprint. So that is how we find the number of strides and what a stride means. So we do it by division, but ensure harmony of the units before any operation is made. Ensure I've got the same units, preferably convert the greater unit to a smaller before the division is made. Then part B, how far does he run? How far does he run in 200 strides? Remember, every stride, that is 1 stride, is of 180 centimeters. What about 200 strides? To be 200 times 180, where 18 times 2, here you get 36, and add on 3 zeros, so you get 36,000 centimeters. So this Ivan will go as far as 36,000 centimeter distance when he makes 200 strides. If you want to convert in meters, like the question here is open, you can leave it in centimeters, or if you want, go to meters when you divide this by the equivalent of a meter in terms of centimeters. Remember, 1 meter is 100 centimeters, so you state very well 100 centimeters make a meter. What about 36,000 centimeters? 36,000 divided by 100. 2 zeros, of course, we go off. So we go as far as 360 meter distance if you wanted to go to meters. But here you will get the answer, you get the maximum marks because the question was not open. So we go, sorry, it was not closed, so it was open. You can answer in centimeters, you can as well answer in meters. So we go to number 2, example number 2, and see what it has for us in terms of length. Now we start. Telephone poles are 4 meters apart. What is the distance from the first pole to the 16th pole? So they are placed 4 meters apart, meaning from one pole to the other we have 4 meters. That's the interval at which these poles are placed. So if that's true, we must know how many 4 meter spaces are in between the first and the said 16th pole. So we go and find the number of spaces. Number of spaces is equal to last pole minus original pole. Last pole position minus original pole position. So the last pole here is positioned at number 16, and the first one, of course, is number 1. So 16 minus 1. So how many spaces each of 4 meters? There are 15 spaces. So we start working out each of 4 meters. Actually, each of 4 meters. So this 4 meters was supposed to be 20 meters actually. So these are poles that are of telephone. So 4 meters apart, which is not working. So it's supposed to be 20 meters. So that the question reads well. The telephone poles are placed 20 meters apart, meaning from one pole to the other is 20 meters. What is the distance from the first pole to the 16th pole? Like I said before, get the number of spaces. Last pole minus original pole, 16 minus 1, and get 15 spaces each of 20 meters. So we say one space is of 20 meters. What about 15 spaces? That's 15 times 20 meters, where 15 times 2 gets 30, and it's this 0. So from the first to the 16th pole, there is a distance of 300 meters. So I beg your pardon, it was supposed to be 20 meters. They are placed or spaced 20 meters apart. So every space that is from the first to the next, to the second, that is, then second to the third, third to the fourth. So I've got that interval of 20 meters. So every space is of 20 meters, and there are 15 spaces were found out. 15 times 20 and gets 300 meter distance between the first and the 16th pole. And now we go to number 3. Example number 3 says the distance around my farm is 400 meters. The distance around my farm is 400 meters. If I want posts for fencing spaced 4 meters apart, how many posts will I need? So these posts can be 4 meters apart. Now, distance around the farm, assuming it's not circular, it's rectangular, or it is square, or any other polygon. So distance around any polygon is called perimeter. So this is application of perimeter in daily life. So we say number of posts equals that distance around divided by the interval. Different distance around is termed as perimeter. You say number of posts equals perimeter divided by interval. So let's see the units and see whether they are in harmony. These are 400 meters, this is 4 meters. Glory be to God. Both are in meters. Then you have freedom to just divide and get a number of posts. That's 400 divided by 4. So that you have got by 4 ones and the 2 zeros. So how many posts are needed to fence my farm? I need to buy as many as 100 posts. Sometimes they are called poles, and this is called posts, just a post. So, in order to fence, remember you erect posts around on which you mount what's called barbed wire. So, why do you do that? Because you want intruders not access your farm. or you want your herd or your cattle not to go outside or beyond your very farm. So you have to use barbed wire so that you are safe. In two ways: one, your cattle will not get lost; then two, the intruders will not access your farm. So that's 400 divided by 4. That is perimeter divided by interval. So the word this is around brought the meaning, which is perimeter, which is technical in mathematics. So we call it perimeter. So perimeter divided by interval, you get a number of posts, and then you get 100 posts that you will have to have in order to fence that garden successfully, thereby applying perimeter. Whenever you see a fence, you just know that's application of perimeter. So the use of perimeter is for security reasons. So whoever's got a fence, you have applied perimeter. You are learning at school in daily life so that you are secure. That's what's called a perimeter wall you have around. So you have applied perimeter, and then mathematics will be at work. Then we P7 members, number 4. Example number 4 is about a ladder. You know a ladder? Yes, now we are talking about it here. You know, some people may not know that mathematics is practical. They only think about money, but even beyond money, mathematics will be used, even at home now. So see a ladder. A ladder leans against a wall. Have you ever seen one leaned against the wall? Okay, that is mathematics, to form a particular shape. Okay, the distance between the foot of the ladder and the wall is 4 meters. The top of the ladder is 5 meters from the ground. What about mathematics now? Calculate the area of the space between the ladder and the wall. So we can never answer this unless we think about the polygon that is formed by a ladder just leaned against the wall. Let's see. You know, the walls are ever vertical. The walls you have there are ever vertical to the ground. They are perpendicular. So this is the wall, very straight. And now, if a ladder is leaned against the wall, a right-angled triangle is formed. Just right at home, you see. You lean a ladder against the wall. So, if the wall is just vertical like they are supposed to be, then when the ladder is leaned against it, like this, you will see a triangle like this. And now let's see the description. The distance between the foot of the ladder, this is the foot of the ladder, and the wall. So, and the wall, between the foot of the ladder and the wall is 4 meters. So, it will be the base of that right-angled triangle. That's why I've got 4 meters here. And then the top of the ladder is 5 meters from the ground. Okay. The top of the ladder is 5 meters from the ground. So the top is here and this is the ground. So the top of the ladder is 5 meters from the ground of that very ladder. So this will be that longest side of the right angled triangle, which we call hypotenuse. Hypotenuse. Look at the spelling. Hypotenuse. Hypotenuse is the longest side of a right angled triangle. So the ladder makes the hypotenuse and makes the longest side of a right angled triangle. Now the question is, calculate the area of the space between the ladder and the wall. So they want you to find the area of the entire thing here. The shape you have seen is a right-angled triangle, and whether right-angled or scalene, all equilateral The area of any triangle is got by the formula a half times base times perpendicular height, like we learned from P4. Now we and P7. So we didn't know that much. P4, 5, 6. You must have reached perfection at P7 level. So whenever you lean a ladder against any wall, a triangular kind of shape will be formed in between that ladder leans against the wall and the wall itself. So this is the shape. So now about the base of the triangle, let's think about the triangle or the base shape and the hypotenuse of the triangle, which is the longest side of the right angled triangle. But now they're asking us for the area. So which area is found by the formula said a half times base times perpendicular height. Now as we see here, we have the base but no perpendicular height, meaning the height of the wall is missing, and we don't use the hypotenuse in that formula. We said a half times base times perpendicular height. So there's no provision for this 5 meter length for a ladder. So we want the 4 meters as well as the perpendicular height. That's the height of the ladder here. Thereby going into what we talked about in B6 called Pythagoras theorem. Pythagoras theorem. So Pythagoras, and you can put apostrophe because it was a person. Pythagoras theorem. Pythagoras theorem, which we talked about in B6. We said when the height is squared for a right angle triangle, please applicable on right angle triangle only, like this one. So when the height of the right angle triangle is squared and then added to the base squared, or square of the base, you get the hypotenuse squared. So we labeled the height A, we labeled the base B and the hypotenuse C, and then we state A squared plus B squared is equal to C squared. That is the flow of what is called Pythagoras theorem. So having known Pythagoras theorem, then we can apply it like we did in P6. P7 is about application of knowledge we acquired in the entire primary, the other 6-year time. That is from P1 up to P6. Then P7 we applied. Now that we learned about Pythagoras theorem in P6, so we applied here. When do we apply Pythagoras theorem? The answer is when given 2 of the sides of the right angled triangle and we need 1. So like we see, height is missing, we don't have the height, that is, we have the base and the hypotenuse. So we use Pythagoras theorem to get the height. So I said when the height is squared, add it to the square of the base, you get the square of the hypotenuse for any right angled triangle. Not any triangle, but a right angled triangle. Why do we do so? Because the area requires us to use the perpendicular height as well as the base. That's what I'm saying. A half times base times perpendicular height. So there's no provision for hypotenuse, which is the longest side. So it only helps us to find the height of this wall or the height of this triangular kind of polygon. So we say A squared plus B squared equals C squared. Then we substitute accordingly. So at A we've got H, right? H squared. Then we go at B, we have got 4 meters. 4 meters, still in brackets, squared. Please, must be in brackets, squared. Meaning the whole of it must be squared. That's the 4 as well as the meters. Then at C, we have got the hypotenuse of 5 meters. Right, 5 meters, then squared. Then square them. So leave H squared because it's unknown. Now, square is 2, 5 and 4. So both are meters. That's plus 4 meters times 4 meters equals 5 meters times 5 meters. That's squaring them. And now get the outcome of the squares. So h squared plus 16 meters squared. Why? 4 times 4 is 16 and meter times meter squared. You get 16 meters squared, then 5 times 5 you get 25. Meter times meter you get meter squared. So thereby attaining a statement that reads hey h squared or h squared plus. So I say h squared plus 4 meters times 4 meters, t in brackets equals 5 meters times 5 meters. Now you evaluate whatever is in brackets here. So this h squared remains h squared, then 4 times 4 you get 16, then meters times meters, you get 16 meters squared, or you get meter squared, then 5 times 5 you get 25, and meter times meter you get meter squared, thereby attaining 25 meters squared. So the statement is h squared plus 26 meters squared equals 25 meters squared. If that is true, then algebra has it that when you are given any sign to solve the problem, bring its corresponding opposite. So the opposite of plus sign of addition is a minus sign of subtraction. So do we subtract 16 meters squared from either side, thereby doing what's called collection of like terms. So you see 16 meters squared and 25 meters squared are both meters squared, so they look alike, so they're like terms. So do we collect them, and when the plus sign crosses the equal sign, becomes a minus sign of subtraction. So do we deal with that in that sense? We go h squared plus 16 meters squared minus 16 meters squared equals 25 meters squared minus 16 meters squared. So 16 minus 16 is a 0. So this side will remain with only h squared. H squared plus 0 is the same as h squared. So then we subtract this 16 from 25. Subtract arithmetically. Good. You have 9. So I've got 9 meters squared. So h squared is got 9 meters squared. Now what's uniform here? The square and square. So both are squares. So opposite of square, algebra is like that. Opposite of square is root of the square. We normally call square root. So we find square root either side. So this side and the other side, that is the square root of h squared is equal to square root of 9 meters squared. So whenever a square and square root are near each other, both go off. So therefore remain h and here meters, thereby finding the square root of a number 9. So the square root is ever found by prime factorizing. So we prime factorize 9. So prime factorizing, like here, prime factors. The factors must be prime numbers. The first prime number is ever 2. Now the question is 9 divisible by 2? Never. There is a remainder. Then the next prime number after 2 is 3. Can 3 divide this 9 really? Good. If it can, then proceed. We say 9 divided by 3 is a 3, and then still divisible is 3 by 3. You say 3 divided by 3 is a 1. Then pair here, that is square, get the root. Square here, get the root. So root of this square, get a 3. So you tie two things that look alike and bring out 1, and get a 3. So the square root of that 9 is a 3. So meters are already here, so the height of this wall, of this right angled triangle is 3 meters. So the wall is 3 meters high. If that is true, then we have the height of the triangle and the base, which are the necessities to find the area now. The question reads and reads, calculate the area of the space between the ladder and the wall. We have seen this space is triangular. Find that triangular space in terms of a shape. So we go area equals a half times base times perpendicular height. So two lines are said to be perpendicular if they meet at right angle. So this is the perpendicular height which I've got at 3 meters and the base is 4 meters. So we use them here. Area equals a half times 4 meters times 3 meters. So that we divide 4 and 2 by 2. 2 divided by 2 once, 4 divided by 2. You get a 2. So I've got 2 meters times 3 meters, thereby getting 6 square meter space. So that is the answer. So area equals 6 meters squared, and that's all. So one that did not follow my lesson would hardly tell that they're talking about area triangle here. They're talking about a ladder, a wall, and many things. You can hardly think about a square. Sorry, about a triangle. Please, whenever lean ladder against a wall, a triangular shape is formed just in between there. So we look at example number 5 today. It reads, find the value of B in the figure below. Again, the figure is a right angled triangle. The moment they give us 2 of the sides and they are wondering about the third, or think about that theorem called Pythagoras theorem. So we apply Pythagoras theorem. Remember, in the number before us, number 4, we are lacking the height, now we're lacking the base. So we label. For label number A will be the height, B will be the base, and then C will be the hypotenuse. So we start. A squared plus B squared is equal to C squared. As it is here. So then we go. The A is 5 centimeters. Now we say squared plus B squared remains B equals 13 centimeters. Please in bracket squared. Then you expand like I've done before. 5 centimeters squared means 5 centimeters times 5 centimeters in brackets plus B squared equals 13 centimeters times 13 centimeters. Derived from here. And then we multiply 5 by 5 get 25 centimeter base centimeter squared. Plus B squared equals, 13 times 13. So is 169. 169. So 169 makes centimeter base centimeter squared. And now we collect like terms, both are centimeter squared, that is 25 centimeters squared and 169. So therefore they are scattered. Now 25 is a positive integer here, so it crosses the equal sign and becomes a negative. So we are going to subtract 25 centimeters squared from both sides. That's 25 centimeters squared minus 25 centimeters squared plus this B squared equals what is found this side. 169 centimeters squared minus 25 centimeters squared. So 25 and 25 both centimeters squared. When subtracted you get a 0. So remain with B squared this side. Then we sum 169 and 25 through our side work. And 9 minus 5 you get a 4. 16 minus 2 you get 14. So thereby getting 144 centimeters squared that side. So we have B squared equals 144 centimeters squared. Now both are squared, introduce the square root for the squares to go off. So the square root of B squared equals the square root of 144 centimeters squared. The square root of B squared is B, and the square root of centimeter squared is the centimeter. Then we prime factorize 144 to find the root of the square 144. So we start. We go prime numbers. The first prime number is 2. Fortunately, it can divide this 144. 144 divided by 2. 14 divided by 2 gets 7. And 4 divided by 2 gets 2. Then still it is divisible by 2. So because a number is divisible by 2 if the digit under the place value of ones is one of the first 5 even numbers. That's 0, 2, 4, 6, and 8. So indeed, it qualifies. 72 qualifies to be divisible further by 2. So 7 divided by 2 is the 3 remainder 1. The remainder is written against this next number and get a 12 divided by 2. You get a 6. Since that 6 is divisible by 2 because of the 6 under ones. So 3 divided by 2 get 1, remainder 1. The remainder is put against 6 and get 16. 16 divided by 2 you get 8. So you get 18 here now. So 18 divided by 2 you get 9. Now 9 can no longer be divisible by 2. You go to 3 as the next prime number. 9 divided by 3 is a 3. And then 3 divided by 3 you get a 1. I told you pair numbers that look alike to produce 1. So that square is better root. So square to better root, you rate a 2. Square this, pair this and that, and get a 2. Pair this and that and get 3. Multiply those paired ones. So multiply those outcomes. 2 times 2 and times 3. Where 2 times 2 is a 4. 4 times 3 you get 12. So the square root of 144 is 12. So B equals 12 centimeters. The value of B is 12 centimeters. And that is it. That is application of Pythagoras theorem onto a right angled triangle. Then part B, we go find its area. Find the area of this triangle. Now that value B is the base, which is 12 centimeters, and the perpendicular height is 5 centimeters. So you state area of the triangle equals a half times base times perpendicular height. Area equals a half times our base of 12 centimeters times our perpendicular height of 5 centimeters. Remember not to use hypotenuse in area, so don't use this 13, therefore. We say 2 divided by 2 once. Then 12 divided by 2 gets 6, thereby remaining with 6 centimeters times 5 centimeters. Where 6 times 5 is 30, then centimeter per centimeter. You get centimeter squared, so the area of this triangle is 30 centimeters squared. All in all, one needs to know how to find the unknown given two of the sides of the right angled triangle. When does one then apply Pythagoras theorem? When such a scenario happens, you are given two of the sides of the right angled triangle. Only on the right angled triangle, please. Where you see this sign here, it shows that's the right angled. So when you are lacking one of the sides, that's given two of the sides, you then apply Pythagoras theorem. So in number 4, we found the height. Here in number 5, we found the base. Whereas number 6, let's see what is needed. Calculate the value P in the figure below. You see a right angled triangle. Two of the sides are 6 centimeters and 8 centimeters for the height and base respectively. They are in need of the longest side, which is called the hypotenuse. Now we are finding the hypotenuse. The hypotenuse is the longest side of a right angled triangle. So it's the one we need now. So do we apply to find the C? So you label well without any change whatsoever. A is the height, B is the base, and C is the hypotenuse. So we start. A squared plus B squared is equal to C squared. So the height is 6 centimeters now squared plus the base. That is 8 centimeters now squared equals P squared. So it is a P now. So find the value P. So expand these squares. 6 centimeters times 6 centimeters in brackets plus 8 centimeters times 8 centimeters equals P squared. Where 6 times 6 is 36, centimeter times centimeter is centimeter squared, thereby obtaining or attaining 36 centimeter squared there. 8 times 8 is 64. Centimeter times centimeter squared, you get 64 centimeter squared, which is equal to P squared. So now we are going to add 36 and 64. Add it there and tell me what have we got? Good. 100. So it's 100. So 100 centimeters squared equals P squared. 100 centimeters squared is equal to P squared. Wherever we reach here, remember we want P without any encroachment. So there's a square on P. So to eliminate the square onto anything, bring the opposite. Opposite of the square is the root of the square, called square root. So we find the square root to either side. That is the square root of 100 centimeters squared equals the square root of P squared. The square root of anything squared is that very thing. So the square root of P squared is P. And now the square root of centimeter squared is a centimeter. Now let's find the square root of 100. In other words, which number can you multiply by yourself to get 100? I know you know it, but it's better to find it then. So show the examiner you need to know, even if you know, and then you will know that you have all the knowledge about how to reach the answer. So 100 is divisible by 2. 100 divided by 2 is 50. 50 divided by 2 is 25. Now 25 is not divisible by 2. We go 3. No, it's not a multiple. We go to the next prime number after 3. That's a 5. So indeed it is a multiple. Now 25 divided by 5 is a 5. 5 divided by 5 get a 1. Now like I've done for the previous two examples, we get the root of the square by squaring. Square and get the root 2. Square and get the root 5. That's 2 times 5. You get a 10. So P, or 10 centimeters, is equal to P. And therefore P equals 10 centimeters. So that's hypotenuse. That's how I find the hypotenuse. The other day we asked you for the perimeter of this shape. You just label side 1, side 2, side 3. You say perimeter is equal to side 1 plus side 2 plus side 3. So you go, perimeter is equal to 6 centimeters plus 8 centimeters plus what I've got here as 10 centimeters. Add around, you will be able to get the answer as 24 if I'm accurate as 24 centimeters. Remember, don't put square onto perimeter, please. Just maintain the units. If they are meters, put meters. If they are kilometers, please use kilometers. But here we have learned how to apply Pythagoras theorem, and now it's applicable only if you are missing one of the sides of a right angled triangle that is availed with two of them, and then you label ever. A will be at the hypotenuse, B will be at the base, A will ever be at the height, B will be at the base, and C will be at the hypotenuse. So A at the height, B at the base, and C at the hypotenuse. So that is what is supposed to be done as we go to number 7, which is the last example for this lesson. So find the area of the figure below. Find the area of the figure below. So look at the shape and then you answer. Which shape is this one? Someone say the rhombus. No, it's not a rhombus. A rectangle? No, it's not a rectangle. Okay. Ivan said it is a parallelogram. This is called a parallelogram. You must have learned how to identify shapes from the other. So please, this is called a parallelogram. Area of parallelogram equals base times perpendicular height. Base times perpendicular height. Right here, area equals area base times perpendicular height. The base is 10 centimeters and the perpendicular height is 7 centimeters. So do you substitute accordingly? That is area equals 10 centimeters times 7 centimeters. Multiply properly and get 70 centimeters squared. That's the area of that parallelogram. You must then master the formulae or different formulae finding the area of different shapes, like we analyzed in the previous classes. Please ensure you know how things are done. So even the previous term, that's term 2, we talked about such areas. So we then get that ability to answer all the activities for the 8 pages. That's 1 up to page 8 of our term 3 workbook. Ensure you answer accordingly. I'm Teacher Katimbo and Simple Teacher Katimbo Richard. And for more information about mathematics in general, reach me on 0776 251655. That is the MTN line. I repeat, 0776 251655. You can as well use the Airtel line 075 7233066. Otherwise, that's the end of the lesson. Please, COVID-19 is real. Therefore, stay safe and bye-bye.